just looked around you? I mean, really looked. At the crazy vibrant red of a coffee cup or the deep blue of a shampoo bottle, our whole world is just drenched in an amazing spectrum of color. But have you ever wondered, where does all this modern, super intense color actually come from?
Right. Where does it come from? It's easy to just take it for granted. You might think it's some kind of magic or maybe just a happy accident of chemistry. And honestly, you're not that far off. It's a story of incredible science, all happening on a scale so small it's almost impossible to imagine.
You see, the source of all this brilliant color has been hiding in plain sight this whole time. It all comes down to these microscopic powerhouse particles called pigments. These are the invisible workhorses that literally give color to almost everything we touch and see in our modern lives. So to really pull back the curtain on modern color, we have to zoom in on one very specific type of these particles: organic pigments. These are the true heroes of our story today. So what in the world are they? Well, these aren't your ancient ground up from a rock kind of pigments. Nope. Organic pigments are totally modern, man-made marvels. They're these complex molecules built around a carbon backbone. And it's their unique chemical structure, the very specific way their atoms are bonded, that's the magic trick. It allows them to absorb some wavelengths of light and reflect others right back at our eyes, which creates the color we see. Now here's where things get interesting, and it's a super common point of confusion. To really get what makes a pigment, you have to understand how it's different from its very close cousin, a dye. The difference is actually really simple, and it all boils down to one crucial property. And that keyword is insoluble. A pigment is insoluble. It does not dissolve into whatever it's trying to color. The best way to picture this? Think about dumping sand in a glass of water. You can stir it up all you want, right? But those little sand particles are just floating around. They're dispersed. They never truly become part of the water. That's a pigment. A dye, on the other hand, is the total opposite. It's soluble. It dissolves completely into whatever it's mixed with. This time, think of adding a spoonful of sugar to your coffee. The sugar crystals just disappear. They become one with the liquid on a molecular level. That's a dye. And this one simple difference, soluble versus insoluble, dictates everything about how they get used. Because pigments are just these tiny dispersed particles, they're perfect for coatings that sit on a surface, like paints, plastics, and inks. Dyes, because they dissolve, are used to color things from the inside out, soaking into materials like textiles or leather.
Okay, so now that we're in the pigment family, let's peel back another layer. We're talking about organic pigments today, but what about their counterparts? Inorganic pigments.
It's really all about trade-offs. The organic, carbon-based pigments, they're the rock stars. They give us those incredibly bright, vivid, almost neon colors, and they tend to be pretty transparent. But their weakness? They're not always the toughest when it comes to sunlight and weather. Inorganic, mineral-based pigments are the exact opposite. They give us duller, earthy tones and are way more opaque. But boy, are they tough. They can withstand the elements like a champ.
And this quote just hits the nail on the head. You've got that electrifying look at me pop of an azo red. That's your organic pigment. Then you've got that classic, rustic, barn door color of an iron oxide red. That's your inorganic. Two totally different pigments for two totally different jobs. You can just picture it, right?
So what is it that makes these organic pigments the superstars of the modern color world? Well, it really comes down to a couple of key superpowers that defy just how good they are at their job. Superpower number one is coloring strength. This is pretty much exactly what it sounds like. It's a measure of how much coloring punch a pigment has. How intense of a color can it produce with just a tiny amount? And why does that matter? Oh, it's a huge deal. It all comes down to efficiency. If you have a pigment with really high coloring strength, you need to use way less of it to get the color you want. That makes things cheaper to manufacture. And on top of that, it's what lets us create those really vivid, saturated, eye-catching products that we all love. All right, superpower number two is hue. Hue is basically the color's true identity. It's what lets us say, that is red, or that is blue. For a pigment, having a really precise and stable hue is everything. It's the foundation for getting color exactly right every single time. And in the real world, this is absolutely critical. I mean, think about a company like Coca-Cola or Tiffany. That specific red or that specific blue has to be perfect every single time on every can, every box, all over the world. A high-quality pigment with a consistent hue is what makes that possible. It's the secret sauce for color matching, and it's a major sign of a pigment's quality.
Okay, so we know what they are. We know what makes them so powerful. So where do these incredible little particles actually end up? Now that you're in on the secret, I promise you are going to start seeing them everywhere.
You're seeing them in the very coatings that protect and beautify our world. The paint on houses, that glossy finish on a car, the colorful shell of your laptop, all of that is thanks to the power of these pigments, suspended in a liquid, providing both amazing color and a layer of protection. In fact, organic pigments have 3 main industrial playgrounds where they are absolutely essential. Coatings, like we just saw, plastics, think of everything from kids' toys to car dashboards, and inks, for printing everything from magazines to the logos on your food packaging. These 3 industries use up the vast majority of all the organic pigments made. And it's that perfect storm of qualities we've been talking about that makes them the go-to choice. You've got their incredible coloring strength, their teeny tiny particle size that makes for a smooth finish, and their diverse chemical structures, which chemists can tweak and tune to create an almost endless rainbow of colors. So the next time you see a brightly colored object, anything at all, take a second and just appreciate the mind-blowing science behind it. Because now you know the secret, it's not just color. It's a hidden universe of tiny, insoluble, carbon-based particles all working together to make our world a more vibrant place. So the question is, can you ever really look at the world the same way?